We can understand the cycle of operation of a refrigerator by the following example. If we had a tube closed at one end with a piston or plunger that could turn it into a variable volume chamber filled with air at room temperature, say about 25 degrees Celsius, we would have an air volume with the amount of calories needed to maintain it at 25 degrees Celsius. Now, suppose we push the piston towards the right of the drawing, compressing the air and reducing it to a smaller volume. The calories remain the same, but it would become a smaller air volume but with the same amount of calories, which raises the temperature of this new air volume by, say, about 80 degrees Celsius. Let's go a little bit further in our assumption and imagine that we attach some cooling fins to the tube at the right end. The fins will dissipate the heat into the outside air until the temperature returns to 25 degrees Celsius. Now, move the piston to the left again to return our air volume to its original size. You will now have a large volume for the current amount of heat. Remember that you have already lost your calories by attaching the fins and transferring the temperature to the ambient air. The new expanded air will have a much lower amount of calories, so its temperature will drop to 8 degrees Celsius or even less. This is, in a broad sense, the principle of operation of a refrigerator, whether industrial or domestic. For greater efficiency, a volatile coolant is used so the process of compression and expansion operates continuously. In a practical cooler, the piston is part of a piece of equipment called compressor, and the cooling fins are usually located at the rear of the fridge. This drawing represents the whole system. The compressor continuously pumps the cooling gas into the condenser, made up of a tube with fins attached to it, to obtain high-pressure gas, which becomes a liquid upon cooling by losing its temperature to the fins. At the output of the condenser, there is a capillary tube, meaning thin like a hair. The coolant enters the capillary tube and expands in the next pipe, which takes it to the evaporator, commonly called the freezer. In the evaporator, the liquid coolant is expanded and it evaporates quickly due to the temperature of the food inside the fridge, and it goes back to the compressor, so the cycle goes on and on. The system must compensate for the heat introduced by the compressor motor because its coils become hot as current goes through them. Part of the energy we pay for in the fridge is lost in cooling the fridge motor. Very basically, this is the operation of a refrigerator. A process of compression and condensation followed by a process of decompression and evaporation. All a refrigerator does is pump the heat from inside the fridge and pass it on to the outside air, so the inside is cool. If we open the door with the idea of cooling the kitchen, we will be adding the heat of the compressor motor to the heat already existing in the kitchen. In fact, the less frequently we open the refrigerator door, the more efficient its operation will be. The formulas of coolants have been changed over the decades. The first coolants were based on ammonia, and then other synthetic products replaced ammonia and in turn were discarded since they damaged the Earth's ozone layer. So new refrigerators are becoming more efficient and environmentally friendly. A practical refrigerator has other auxiliary devices that improve its performance, such as controlled thermostats, filters, and dehydrators, automatic defrosting, etc. The makers also improved the efficiency of insulation materials, the door seal, etc. Please subscribe to my channel.